Imitiyass, thank you for joining us at BRICS Africa channel. Please tell us, I see you on the video, underwater, doing research. Tell us more.
Thank you. Thank you, first of all, for coming and speaking to us here today. It's good that we get exposure and get what we do out to the public through the media. So we thank you for guys like you doing the work that you do. So as you said, my name is Imitiyass Mallick. I'm an oceanographic technician and an aquanaut at the National Research Foundation. The business unit that I am associated with is the NRF South African Environmental Observation Network. I specifically work for the Shallow Marine and Coastal Research Infrastructure. This is one of 13 large research infrastructures that the Department of Science, Technology and Innovation have rolled out over the last few years. Another example would be the square kilometer array that we've spoken about quite a bit here at this event. So what we do is long-term observations so that we can understand trends and patterns on our Earth. It's a form of earth sciences. And in order to do that, we use many technologies as what you see here on display. An example would be an ADCP, or an acoustic Doppler current profiler, which uses sound and acoustics and a physical phenomenon called the Doppler effect to track particles through the water column, so that we can understand which direction and speed these water particles are moving at various locations. One of the other devices we have here is called a pulse amplitude modulator. It is an underwater diving fluorometer. So we put on our gear, compressed air, we dive into the ocean with these devices and we measure physical phenomenon like fluorescence. This is relevant to the astronomy field because, for example, solar radiation from that celestial body, our sun, is what ultimately results in the fluorescence we are able to monitor at the bottom of the sea, so we can understand how that radiation changes as it enters our atmosphere and our sea. And then also things like tides, currents, etc. are driven by celestial bodies such as the moon. And when we have other celestial bodies in our proximity, they may have minor gravitational effects on our global currents, such as sea surface height anomalies, or we may find sudden changes in some of our characteristics of our currents as a result of these celestial bodies that we find close to us.
And the environment with these two oceans that we have in Cape Town, the Indian Ocean, Atlantic Ocean, is there a significant difference between those oceans?
Most certainly.
Research?
And this whole thing of two oceans, I think, is underplaying what we actually have geographically in South Africa, because we are in close proximity to a third ocean. In fact, there's nothing between us and this ocean. So on our west coast, we do have the Atlantic Ocean, driven by the slow, cold Benguela current, which is one of the most, if not the most productive currents, inshore currents in the world. Cold, full of nutrients. We have the great African sea forest that grows there, for example, that the Cape Kelp forest, as we like to call them. And then we have the Southern Ocean, because if you go south from here, you hit the only circumpolar current in the world. It's a current that travels right around the whole planet, and that separates us from the Antarctic or the South Pole. So South Africa is geographically placed adjacent to a cold Atlantic Ocean, an icy cold Southern Ocean, and then the east coast has the Pacific Ocean, which actually has the fastest current in the world that passes by South Africa with an average speed of 2 meters a second. That's the top speed of Michael Phelps, one of the fastest swimmers in the world. That is just the average speed of our east coast current.
And you talked about the relevance between the work you do under the water. Has there been, I believe that it's still multidisciplinary science, but how do you guys combine with the astronomers? Do you have these conversations, or how do you guys interact?
Definitely. So we've done some work recently with NASA from the United States. I've done some work on a project called Bioscapes, where South Africa, in particular areas like Alcoa Bay, Walker Bay and the West Coast, were identified by them as key areas of investigation for the work that they're doing. So they came down here, they flew their own aircraft, high-flying aircraft. We had our aircraft, National Research Foundation's aircraft for remote sensing, and then we also deployed two of our vessels, one large coastal craft and one smaller vessel. On these vessels, we had the NASA staff and scientists and researchers with us, with their instruments and our instruments integrated, and we looked at hyperspectrometry, we looked at some things like solar radiation and how those things change as it passes into the atmosphere. So South Africa is uniquely placed to collaborate with astronomers, and for example, one of the National Research Foundation's pride and joys is this square kilometer array that's being developed or co-developed with Australia as well. So definitely overlap. We do engage Earth sciences, and the astronomy field are obviously interlinked, as the Earth itself exists within this solar system.
Within the context of global climate change, when you go down there, what is concerning you when you? I'm sure it must be beautiful with all the different colors. However, I'm sure there must be a few things that have changed over the years.
Most definitely. So there's a number of things that are very easily observable. For example, biodiversity loss, which means that there's a lot of species we no longer find in areas or find at all. We also see things like ecosystem shifts, because as physical things change, like sea warms up or energies get moved to a different area, the ecosystem has to adapt. And when we see these changes, we can identify the drivers that might be causing them. So what the Observation Network does, the South African Environmental Observation Network does, is long-term, dedicated, continuous monitoring, because it's only through long-term data sets that we can understand the patterns of climate change and separate what is anthropogenic, meaning human causing or driven change, versus natural change. And either way, if we understand the dynamics, we can develop early warning systems. For example, storm surges have been happening more frequently along the South African coastline. And as we gather this information, we are able to model and predict better and be able to warn people of impending storm surges, as well as understand what extent it may cause vulnerability to the coastline, potentially evacuate areas, or no longer develop in areas that will become high risk for those kinds of events.
Mallick, thank you so much for joining us on
Absolute pleasure. Thank you very much, Ayanda. I really appreciate you.
Sure.
Thank you.